Hi everyone, this is Apurva, a senior AI developer advocate here at MongoDB. Welcome to another episode of a series called People Who Ship, where we bring you real-world stories from our customers who are building and shipping cutting-edge AI applications into production with MongoDB. I'm so excited to welcome our guest for today, Eno Reyes, who is the co-founder and CTO of Factory AI, one of the hottest AI startups right now. So welcome, Eno. Really thrilled to have you here on People Who Ship today.
Thanks for having me. I'm excited to be here.
Same. All right. So I usually start with a one-line or a few-line intro of the customer, but since you literally co-founded Factory, I'd like to hear it from you. So in a few words, can you tell our audience a little bit about what Factory is and how you all got started?
Yeah, for sure. So I think the sort of context here on Factory is that we believe the future of software development is going to look very different from today. And instead of speeding up one task at a time with IDE-based tools like autocomplete or chat, we think developers, in order to get a 10x productivity increase, must accelerate their work with dozens of agents in parallel. And so we've built the Factory platform to do exactly that. Unify all of your engineering context, so GitHub, G Drive, Jira, Slack, Datadog, all those sources into one place. And then with this deep understanding of your entire engineering system, our agents, which we call droids, can accelerate tasks across the entire software development lifecycle. So feature development, testing, and refactors, of course, but also the sort of edge tasks like technical writing, migrations, even project management work.
Right. And how did this idea even come about? I mean, like I think code gen has gotten really powerful in the past few months, but say like 2 years back, it wasn't that big a thing, and we didn't know that it was going to be this successful. So back then, how did you decide that you were going to place your bets on this one?
Yeah, for sure. I think that there's a lot of different sort of converging ideas that happened 2.5 years ago. I was at Hugging Face, so working primarily with CTOs and VPs of engineering of AI companies or companies that wanted to become AI native. And a lot of these were enterprisey, so they had roadmaps for how they wanted to fine tune models to make a better autocomplete. And when you spoke to them about their goals weren't to make a model. Their goal was eng velocity and productivity, but it felt like there wasn't a clear line of sight from we have faster autocomplete to we have a 10x or a 100x. And so, because at the time there were some initial sort of research poking around the idea of putting LLMs in while loops, function calling, slightly more what I'd call autonomous capabilities. As you sort of like saw this happening at the same time, it became very clear to folks who were in that space that something was going to happen. And then a bunch of pathfinding. My co-founder and I spent a lot of time with VPs Eng, CTOs, and ultimately landed on sort of a platform like Factory. And I think that that North Star of fully autonomous systems has always remained the goal.
Awesome. Well, for today's episode, I would love to dig deeper into Factory's world of droids, like you mentioned, and what it means for the future of software development. So, why don't we start by quickly talking about what a droid is? I'm also curious about your wording of droid, right? You see a lot of folks calling their product coding agents or assistants, but you specifically said droid. So, like, also tell me a little bit about what's different about droids.
Yeah, definitely. One reason why we called them droids is everybody has a definition of agent that feels like it, especially like 2 years ago. This was a very overloaded term. Nobody really knew what an agent was or how it worked. And they were pretty much synonymous with these like buggy systems that didn't work very well. So we wanted to differentiate and clarify that our systems had much more reliability, they had guardrails, and they operated a little bit more autonomously than most people were used to. Over time, that of course has evolved, but I think that the idea of reliability, safety, and still highly capable autonomy remain at the forefront of what we think of as droids. We believe that there are a couple of things that are really important to making autonomous systems work well in an enterprise setting. Memory and learning is so important. Your systems need to correct themselves, not at the scale of a single interaction, but over time, right? And as your team works with them, they should fill in gaps so that your fifth or sixth interaction is actually your team's, let's say, 500th interaction, and you have the benefit of all of the learnings that the droids have, just like an engineer, right? I think the organizational understanding and context aspect as well is a big reason why the droids are able to operate across all the tasks that they impact. So it's not just code. It's not just navigating a file tree or running grep to find files. It's also looking through G Drive and Jira and Slack and and browsing the web and using a computer control in order to actually access your observability tools, right? These more advanced features make the system more capable at a broader set of tasks.
Yeah, I think what you said right there, like it's not just code. That right there, to me, really highlights that differentiation between droids and agents. So thanks for that. And all the themes around reliability, trust, really excited to dig into that as well. Um, but yeah, let's just structure this conversation a little bit, right? So you spoke about what a droid is, and as I understand, there's a few different droids that you can use on Factory. There's a code droid, knowledge droid, reliability droids, and a few others. So, can you talk a little bit about what their architecture looks like, and do they essentially follow the same design principles, or are each of them built somewhat different?
Yeah, great question. The droids are separate in identity primarily for two reasons. The first, there are some slight differences in how, in the guardrails and the general guidance that we provide the droids. Sort of, you can think of them as like behavioral rules. The code droid should operate with the goal being to create merge ready code changes. The reliability droid works primarily with incidents, incident response, and RCA style problems. And the knowledge droid helps out with technical writing and sort of the broader set of, whether you're planning a migration, you're documenting the artifacts of a code base, or you're creating a plan for a major renovation or refactor. Now, those behavioral guidelines are somewhat nuanced, and I think most people sort of can understand there's a couple of basically secret sauce sprinkles that we put on top. The things that's shared are actually much more interesting because this like contextual understanding and engineering system understanding is sort of the foundation that all of the droids have. The memory, right, is shared. The tools that they have access to are for the most part shared.
Oh,
And
interesting. I would have
yeah,
thought they would look different.
yeah, well, for the most part, a certain tools like search and the CLI and editing files, they're really kind of a shared need. There's a shared need. Now, the knowledge droid, for example, has the web search enabled. The reliability droid has the browser tools like enabled by default, but you can always flip them on and off across all the droids. And the behavioral guidelines are really what sort of keep them that keep them acting in sort of different ways.
When
But
you say, sorry, a follow-up there. When you say guidelines, is it a prompt or are you doing more than that? You did say secret sauce, so I don't want to prod you too much on
no,
that,
no,
but
it's not. It's nothing. I'm happy to talk about it. It's nothing that I'd be too worried about discussing a little bit more in detail. Like the yes, prompting for sure, right? So the base system prompts. Now, the prompting system for droids is dynamic. There's not like one static prompt that you could like copy and paste on the internet. It's in fact a system of interacting components. When you enable or disable certain features, depending on your environment, depending on what stage of the plan or task the droids are in, they will have sort of like shifting sort of behavioral guidelines. And that gets to some of the logic. We try to avoid too much scaffolding because we believe in the bitter lesson. We think that too much scaffolding that's external to the actual agent and the system itself probably will be made irrelevant. But there are certain things that we think are valuable that help sort of guide the agent towards success. For example, feedback from failure cases that are translated to be a little bit more AI friendly. Those are the types of things that we think are helpful to build out because they improve quality in the short term.
all right. So, can you tell me I think we did want to touch a bit on the architecture itself. So, like really
Yep.
quick, could you walk us through the architecture of a droid?
Yeah, yeah, for sure. I mean, it's very similar to what I just shared, right? There are tools, there are prompts, there are and then there's of course the context, which is sort of the most important critical differentiator in a platform like Factory, where your engineering system information is processed externally by our indexing and retrieval systems, and then they are brought in contextually based on the task at hand and when the droid chooses to use certain tools. So when you think about it, there used to be like 2 years ago, honestly, even up until around 6 months ago, there was a huge fragmentation in agent architecture. So people were talking about whether it's a workflow, is that an agent, is it just an LLM kind of series of tool calls? A lot of this stuff was very open discussion. Nobody really knew exactly what design would work, and a lot of our time was spent sort of focusing on context and retrieval because we believe that although it's important to define this architecture, it's likely to change rapidly. This has only continued to pay off because today, I think what we see is sort of a convergence in the agent architecture as effectively a continuous loop where the agent itself decides what actions to take, how to reason, when to stop, and when to continue. And so that looping action of the agent, you'll actually find is pretty common amongst almost all of the coding systems available today in the market, right? Whether you're looking at, yeah, popular CLI based tools, the in IDE based agents, they all effectively share an architecture of keep the agent running while the LLM decides to continue working, let it call tools, and then have it stop when it's done. So that's kind of high level, but I'm happy to jump into the engineering system understanding because I think that that's probably one of the more interesting architectural challenges separate from the agent itself.
Yeah, like tell us more.
Yeah. So I think that the biggest question that we get is how do you actually retrieve information uh, so much more capably and so much quicker than other tools in the space? Like a lot of people will head to head us and they'll find that we're able to grab both code information, of course, but also sort of other engineering system info really rapidly. Tools like Claude Code, which are great, and like Codex CLI are these like CLI based tools, really pioneered a generation of agents that rely primarily on like Grep and like terminal CLI based tool solutions. Um, this is actually a really effective way to search, right? You don't index anything, you simply use ls to view the folders in a code base. You run grep and you run find to find specific strings. You look at code and you sort of almost navigate it the way a human would, right? By clicking around.
Okay,
Um,
interesting. I actually didn't know that they primarily use like just terminal commands to grab info quickly. Okay, that's
yeah,
interesting.
yeah. So they have almost no indexing, right? And it turns out actually very effective. But what we found is that there is a combination of both that native sort of tool use, where you use the terminal, like the CLI, you use grep, but you also use indexing and you use embeddings and you use retrieval in order to get a best of both worlds. Where if there's a collection of information that's clearly related in a complex way, right? It's pretty difficult to actually in one tool call grab all of that related information because code embeddings have improved significantly. Voyage is basically one of the best embedding models. I know MongoDB acquired them recently and has been integrating that product into their suite. And when we do evaluations, we kind of looked at retrieval quality with and without. And what we found, sort of contrary to maybe the trend right now, is that indexing and retrieval is actually still very valuable because you have to think about some of these complex coding relationships that are captured not by any like one dependency or a mention, but instead by high level information that's related to another concept, right? And
Right.
so agents cost money to run.
Yeah.
Every tool call you make is more tokens spent for your users. And so if
Right.
you can in one tool call get all 10 relevant files versus needing to run a view the folder, then run view file 8 times, then trace that dependency back and forth, and then you do that over and over again, you find the same information, but one of them just ran for, let's say, 3 minutes and charged you $1. The other one did it in for less than a cent instantly, right? So we still see a lot of difference in quality from those sorts of indexing based investments that we made early on. In no short, very much thanks to the quality of embedding models that have improved over time.
Very cool. Well, I learned a lot in this little segment. on its own. So thanks for that. One other thing I've always wondered about code gen agents, right? And this is something you mentioned a bit early on, is this aspect of context management. So, for example, if a droid is to go from a user giving it a task to something as involved as a merge ready pull request, right? I'd imagine it need to consider context from an entire monorepo, perhaps, potentially other documentation and organizational knowledge. And even with context windows getting larger, at least in my experience, I've seen LLM still struggling with long context. So, can you tell us about how you deal with this in droids?
Yeah, for sure. There are two approaches here that we've seen uh, increase the success over long context problems. Undoubtedly, model providers are working very hard to increase the like net context window. But what's more important than just can you run that API successfully with a million tokens? It's how much of that is effectively being used by an LLM, right? There are a lot of evaluations that look at like effective context window, and they find it's really different from like the number that's on the spec sheet, right? So one model will say we support up to 1 million tokens in the input, right? And they'll charge you a lot more for that, everything above like 200,000. In reality, there really are almost no models. In fact, as far as we're aware, there are no models that have an effective context window of even greater than 200,000 tokens. Um, and so, what that really means is that you have to be a lot more cautious about just dumping context into the system. Now, one way that you can improve your quality is by giving more context, right? So definitely leaning towards providing more information is always going to be better. But there's sort of a trade-off of as you increase that context, the quality sort of sees a bit of a drop, or
Yep.
you sort of have to treat it as a little bit more lossy, right?
Right.
And so the strategy here is to one, be really careful about what you retrieve and what you
Right.
include, and try to do as much processing of that retrieval process outside of the agent loop so that you can basically only select the critical information and bring that in. The second side of things is, most agents that run for very long periods have some form of compaction or compression or sort of continuous synthesis that summarizes the information that has been accomplished so far. And we call this like broadly a set of like problems related to long-term goal-directed behavior. You have, let's say, hundreds of actions you want to chain together. You have a singular goal that you're fighting for, and that agent needs to really stay on track as it gets to that goal, despite running through millions of tokens well outside of the context window. So we have a system that we built to basically enable that.
Okay. So, and the system that you built, is it a tool that the agent can use, or is this just like a background task that's compacting information that the agent is using?
Yeah, great question. The way that the way that it works is definitely a little bit closer to, I'd say, background task,
Okay.
where in the system itself, there's a need to keep the session going, and so you basically can do a lot of sort of clever engineering things to extract out the most important information and provide the agent both a like sort of opportunity to decide what matters without needing to actually see every little like specific log line or piece of context over the course of a session. This is something that we're really excited to actually share more about. We'll probably do a technical blog about it because we think it's like one of the more interesting problems. How do you make sure that agents can stay on track for very long periods of time? And we think our system's pretty good at it, but even naive solutions work pretty well. So I think that this is something that agents themselves will also get better at over time.
Yeah, I'd like to think so. I did a little bit of a toy experiment a while ago where, yeah, I was basically having the agent self-select when it should like create, update, and retrieve its memories, and it did pretty well at that. And yeah, I'm pretty optimistic that it's going to get better too. But I'm looking forward to that blog whenever that comes out because, yeah, I do think this is a really interesting aspect to go deeper on. So,
For
uh,
sure.
for folks listening, keep an eye out for that as well. Another aspect of droids, right? Context management was one, but just this aspect of how to balance autonomy versus while still maintaining reliability of outcomes. Can you talk a little bit about the mechanisms there? Is it basically self-reflection? Is there a human in the loop? Some other secret sauce? What's that looking like?
Yeah, I think that the biggest unlock for autonomy is verification, right? So, in order to be reliable, you have to be able to validate against some sort of goal outcome. And that is sort of at the center of our philosophy around droids. They need to be operating in ways that are where they can validate that they've achieved the goal that they actually set out to achieve, right? So, to some extent, you can sort of think of this as a process of specification, delegation, and then review of that delegated work, right? Where a droid can say, okay, I'm going to implement something in X, Y, and Z form, and I'll validate that by running, let's say, a test, right? Then it's the droid's job to follow through with X, Y, and Z as faithfully as possible, run the test, and if it succeeds, then go back to the user and say, okay, it's time to review my work because I've done, right? And if it fails, then it's on the droid to iterate continuously until it can achieve that outcome, or it discovers some sort of critical information that forces it to adjust plan. And so this sort of process can really be tricky to nail for a broad set of tasks. So you have to start to just be really specific about, hey, what are the tasks? For example, coding has a very clear outcome, which is a code change, right? Um, that's the code droid really sort of is built around this idea of code changes are for the most part verifiable. And so let's make sure that while making a code change, we verify it. For the reliability droid, right? Incidents have a sort of process by which they can be RCA'd, and a outcome of delivering an RCA or delivering sort of an incident triage or even a mitigation itself, right? Landing some sort of, let's say, CLI command or code change that fixes the incident. These are all verifiable because you have signals from the observability tools. And when the human reviews, right, they're oftentimes reviewing A, is this the correct action to take before it gets taken? Or B, if the action was already taken or it's less, write more read, then the human can sort of read through and validate the outcome. So I could go on, right? But the point is that there's always some sort of uh, static or deterministic validation that a droid can make. And then there, for the fuzzy in between and for the parts that are less concrete, a human is really their role is to review that outcome.
Makes sense. Ha- is there also a way to just account for ambiguity of human inputs? Like sometimes, even though the task itself might be clear, like the human themselves might not express the task as
Yeah.
clearly. So, how do you account for that in a droid?
This is a big part of our behavioral guidelines for the droids. They are sort of like truth seeking and information seeking by default. So if you come to it with a plan that says, I would like you to go in and find every import that doesn't follow this ESLint rule and fix them all with this new transformation, and then go and run the test suite. And if it fails, fix them. That's a great plan, by the way, to hand an agent. A
Right.
coding agent like a droid will crush that plan. You
Yeah.
said you told it exactly where to look,
Very
what to do,
clear.
how to fix it. It's going to go in and do it. Um, if you then say, could you please fix some of my ESLint errors? They are annoying me, right? The droid has way less to go off of. Now,
Right.
because of things like organization memory, because of its own memory of its user memory, right? Its interactions with you, there's a non-zero chance that it's actually going to still infer sort of what you mean. But what's going to happen is that droid is going to take that context and it's not going to make a guess here. It's going to come back to you and say, here's my plan of how I would approach that. But I want to ask you a couple of clarifying questions because you were ambiguous. So,
Yep. Okay. Perfect. I love that approach. All right, switching gears a little bit. We've spoken about like the technicalities of droids, but I think I also want to talk a little bit about the bigger picture and where you're going with factory, right? So, um, tell us a little bit about how you envision tools like factory improving developer productivity at large and impacting the future of software. And in its current state, how do you see developers leveraging factory to maximize productivity?
Yeah, totally. We kind of touched on this a bit at the beginning with this idea of the future of software development, right? And how it's clearly the workflow for a software developer is changing in real time in front of us. We had for a long period of time IDEs, which were these tools that are focused on helping a developer read through lines of code, make manual modifications to individual lines of code, and then giving them debuggers and visibility into the sort of like feedback loops that they need in order to complete what I would call the inner loop of software development, right? So this is that flow where you know what you're building already. You know at least what code base to work in. And then you are really going through a loop of look at the code, read it, understand it, make a modification, test if that worked, then move on to the next step and it's kind of loop until complete, right? That inner loop of software development, we believe, is going to be entirely automated with agents. Now, the outer loop of software development, right, which is uh, the higher order thinking that developers do, and this is actually where they spend probably like 40 to 60% of their time already. This is the what are we actually going to do? How are we going to approach solving this problem? Who else on my team has the context? Where do I need to communicate and share this? What are the concrete specifications needed? And of course, let me review these changes to make sure that everything was actually in line with the specification, right?
Right.
This outer loop we think is going to
Mm.
remain very human involved with a great degree of AI assistance, of course. But this is what humans are actually really good at, and agents are not as good at, admittedly.
Do you
And
think they'll
so
get better at that though?
oh, for sure. I think that the way that they'll get better at it though is sort of they will get better at assisting human beings who are defining the sort of higher order goals. Ultimately, an agent that's just executing on its own is, I think, a little bit further out. You can totally imagine that there's sort of these like fully autonomous sort of like organizations where you have some KPIs and you have some product surface and the agent just iterates on like business goals and changing the code base, but I think that realistically, for very complex businesses, and not even for simple businesses, um, this is not really a architecture that is necessary because human beings will probably be the more cost effective option, honestly, than running an agent for let's say human like many human years of compute inference time as it runs through all the different possibilities. Humans have a lot of like capabilities in this area. I don't think agents are anywhere near capable enough to make this sort of very ambiguous decision making. And also, human beings have external motivators that make them very clear, like sort of pictures for who should drive this process, right? Like, as a human, you're sort of coming in and saying, this business should do this thing in order to solve this problem. But there's like an infinite problem space, right? So maybe you'll have an AI that helps you come up with an idea. You'll have an AI that helps define KPIs or like tools that help define KPIs. You'll be able to set up feedback loops. But ultimately, I think this is sort of straying from the more real world. Like if you are a large enterprise business today, right, that sells to you have greater than let's say 10 bill ARR, you are extremely fragmented in your business units, right? You have thousands of engineers. The reality is that organization is not going to be run by AI anytime soon. It will be
Okay.
assisted by AI, right?
Right.
And I think that in the software org of
Mm.
organizations like that, this sort of outer loop can really be defined by a process of like specification, delegation and management, and review, right? Those are the things that humans are gonna for sure be heavily involved in for years to come. And it's that loop that we think humans should get really good at. And it's also that loop that will unlock the more 5 to 10x performance gains. Because if you spec something out, then you can split it up into sort of, you can decompose the task, right, into parallelizable units. And that is just a faster way to work. Parallelization versus serial improvements. This is like we learned this with GPUs, years ago.
Yeah, but that's really encouraging to hear that someone who is like working really in the weeds of something like just transforming the future of software still thinks that there is a place for humans and just I really like how you thought of the inner loop versus outer loop. I really like that way of thinking. So thanks for that.
No, for sure. I think that there's a lot of I've mentioned this before. To internally and also to friends when we talk about this. But there's a lot of incentive right now in the market. If you are a, like, let's say, foundation model lab, or you're a someone who sells AI coding tools in particular, to sort of say something like, oh, in 2 years, don't worry, my tool will replace human software engineers. So instead of paying those humans, let's say, $50 million a year, what if you paid our company $50 million a year, right? That's sort of the
Oh,
angle.
okay.
And I think that incentive is such that people are willing to sort of inflate the real impact. I
Yeah.
do think it'll be extremely transformational, but
Yeah.
it's going to mean that human beings' role is just going to rapidly adjust, not that they're going to be
Right.
removed from the picture.
Yeah. I really appreciate that you kind of there's a very grounded response, and I think we need more of that in just AI right now. So that was great. I'm also curious if you dog food your product. So, are your developers using Factory itself? What does software dev at a place like Factory look like right now?
Yeah, totally. I mean, I think this process of like specification, delegation, and review is certainly how we think about our own internal development processes. Another thing is validation. So we spend a lot of time thinking about how can we make it easy internally to validate our agents' work, and also to provide guidance and rules and guidelines for AI systems. Like whenever we make a dev change, we're let's say like a DevX change, like, oh, now we use these tests, or hey, now we run this command before. We're actually more likely to communicate that to our agents, our droids, than we are in Slack internally, because ultimately that's who it matters for more. We've theseus shipped ourselves, in the sense that basically 100% of the code from Factory is generated by an older version of Factory. And so humans are definitely still very involved, but in reviewing, and they make edits, but the vast majority of the code is effectively droid created.
Wow. And what have some of those improvements looked like from one version of Factory to to the next? Like, what kind of speed ups are you seeing right now?
Yeah, the crazy thing is our team has, like, when you control for the number of folks on our team, our
Hmm.
productivity sort of just looks like a straight vertical line, sorry, not vertical, a straight diagonal line,
Diagonal
where,
line.
yeah, where our like pace per like week just seems to keep increasing, and I think that is for sure in line with the idea that the over the last like 4 to 6 months, we've really seen the biggest unlocks for agents in our product. And the sort of like current state of things is that our web platform remains the source of the most in-depth and fine-grained control that you'll have over our droids. But we're also releasing interfaces across all of your existing tools, so that you can control droids from basically everywhere, right? So you can control a droid or start a droid from Slack or Jira or Linear. You can do it from your IDE inside of your CLI. And these sort of additional surfaces help developers interact with droids from everywhere. And I think that is going to even more so increase the productivity of our team, because I know that very often we're sort of, because it's a web-based tool, on your mobile phone or on the web, you can sort of do something on the go. But there's a lot of times where you don't really want to even like go into a web platform. You just want to get a Slack update. Hey, this is now ready for review. You can click it, and then you're in review, right? So that's the sort of workflow improvement that we're looking forward to, and a lot of it is driven by just us shipping those features with the droids themselves.
Very cool. Like meet devs where they are, like literally where they are
100%.
doing at any given point of the day. Very nice. The other interesting aspect of coding agents to me is this aspect of trust and safety. Like if I were to use a coding agent and I had to give it access to sensitive information like my API keys or things like that, I think I would, yeah, I would be a little skeptical of doing that. Do you see that trend in general? And if so, like how do you tackle that within Factory?
Totally. For the most part, we actually see a very warm adoption of agents. I think especially in the last year, people have warmed up significantly. But it remains true that our philosophy on deploying autonomous systems in the enterprise is to prioritize safety, responsibility, and transparency. as very critical sort of product features, not just like policies that you put up on the door so that it's everyone says that you agree, but instead like this is like a whole product area and a product surface for us. And so you know, you think about sort of what this process looks like. You know, first you have to sort of define what capabilities are even different or novel or higher risk for an agentic system versus just like, let's say, an autocomplete tool, right? So the
Right.
fact that an agent can autonomously write or modify code, the
Mhm.
fact that it can access or manage the same tools that you do with the CLI, and the fact that ultimately, you know, with permission, you can deploy to production code that you may have completely, you know, like has basically not been touched by a human, only reviewed. And so with those, you sort of have to have this loop of constantly identifying issues, evaluating the risk that these sorts of new problems or potential risks would look like. You have to build out mitigations for those risks. And then you have to be able to monitor for the occurrence of these things in the future. And so our infra and security and trust teams basically spend a lot of time on this aspect, right? Looking at threat modeling for agents, and figuring out ways that we can both red team and monitor for this stuff occurring in production.
Very cool. But I also a quick follow up there, right? From a more user perspective, do you see any hesitance or skepticism when it comes to even letting agents have access to that information, or are people willing to accept that risk and work with you on, okay, I trust you to have the right mitigations in place? And yeah, like, is there that level of trust, or what does that look like?
Yeah, totally. I mean, I think that this is maybe the more, let's say actually like like user facing component of what I just referred to, which is when you have this system, when new problems occur, you sort of figure out what's the solution here. Is it like a back end problem? Is it a like is it behind the scenes basically? So like an example of this would be, you know, integrations, right? Access a bunch of critical information from your engineering system. People obviously are going to be reluctant to just let somebody random enter their engineering system and just start touching data. But you can sort of, if you can go up to this problem and actually sort of start categorizing, right? You say, okay, well, what are the real concerns? Data exfiltration. That's one we hear a lot. What if my AI system inadvertently exposes secrets or code or internal data, right? Destructive actions, right? So you deleted some files, you wiped logs, and now it's irreversible. Security exploits, like the agent generates code that has a clear vulnerability inside of it. Um, Execution misuse. So a malicious actor comes in, and because your agent has access to tools, maybe they think that the actor can take control of the agent and do something they didn't want to. And one that we find really interesting, which we call like deployment context drift, which is basically sort of this inadvertent, I told you to do this thing and you achieved that goal, but you
Hmm.
did a very weird roundabout way that a human wouldn't
Hmm.
have. And along the way, you did something inadvertent that we didn't want
Interesting.
you to do. And
Okay.
so all of these have different mitigations inside of our product, right? Like you think about this inadvertent path. Well, we lay out the plan concretely so that you know how something's going to be achieved. Data exfiltration, right? We have secret scrubbers that and like log parsers that filter on the client side any information that's touching the platform for patterns like secrets and API keys. So from the user's perspective, they know none of it will get stored. And for things like scary actions, destructive actions, all of our commands that we run have like a risk profile associated with them that's actually surfaced to the user. And when you're configuring your droids, you have the ability to set a certain amount of risk that you're willing, like low, medium, or high risk actions that you'd prefer to be autonomously taken, right? And of course, there's certain actions that are straight up blocked because we know that no good can come from an agent automatically running those commands. And so all of this sort of ties into an experience that as a user, you may be a little skeptical about. But then when you actually get in, you see how much control you have. And I think that assuages a lot of fear.
Oh yeah, like 100%. Like, I think the more explainable we can make these systems, the better. And in cases like these, I think I really like all the signals that and controls that you're providing users. So awesome. On a related note, also wanted to ask you, what are some of the hardest problems in the space right now?
Yeah, great question. Long-term goal-directed behavior, that note I made earlier, is really tricky. You really want your agents to do the thing and do it well and do it over a long period of time. And it's difficult to get that right. There's a lot of reasons why an agent is sort of like compounding systems. So like 1% error rate on 9 parts of a flow means that you're going to have a really bad end user experience. So I think that's one thing that's probably pretty open. High quality retrieval is still really tricky. Embeddings are helpful. A system of orchestration for indexing is helpful, but this remains like a very open challenge. And I think that one that is sort of less talked about is just it's very obvious that the final UX of agents is going to look really different from current tools. And I think a lot of people in the space are just sort of iterating right now on what does sort of delegation first UI and UX look like, right? Like we have human project management tools, but AI systems are not human. They're like they basically work forever, like as long as you can pay for them. They work when you're sleeping. They can test many problems, many directions in parallel. So I think we need new UX paradigms for these systems.
Interesting. Well, I think that in itself could be another episode. So I think I'll need to just like stop here right now. But to wrap up, I would love to get your perspective on just what the future of software development looks like. I think you did talk about a lot of this. The UX will needs to look different, the inner and outer loop. But what do you think that future looks like?
Yeah, I think it really does resemble this sort of transformation where software engineers, people who call themselves software engineers, right, are going to sort of transform what they are primarily responsible for. And that role is going to blend with people that we call like product, people that we call data science. Like the idea that you would be a back end only engineer, I think, is going to also sort of transform, right? But basically, all of these roles are blurring together, and humans are going to continue to define the outcomes and specifications of what they want built. They're going to get good at delegating and context switching these systems, and they'll get good at spotting common flaws and errors that AI make. Right, like human editors, right, of like copy. You give them a book that's pre-publication, they'll spot every grammar issue, they'll spot all the common sort of story structures because they've done it. Humans are going to get a lot better at that sort of pattern recognition. And so overall, I think, 5 years from now, you're definitely still going to have people building software, but I think that they'll look a lot more like something in between a technical PM and technical data scientist, where they're sort of asking questions, getting answers, and using that to inform the shape of what should be built, and then letting AI do a lot of the more grounded, like code writing and building part.
Grounded to me was the key word, but I really liked how you framed that. So, well, I really enjoyed this episode. Everything that you said, I think that it gave me a lot to think about, and I'm sure it gave our audience a lot to think about. Most folks who show up here are developers, so I know it got a lot of wheels turning there. So, thank you so much for everything that you shared here today and for your time.
Yeah, thanks for having me. This has been super fun.